So look at the question, we're given an expression for y. So y equals 5x squared plus 10x all over x plus 1 squared. And we're given a condition that x can't equal minus 1. And part A says we need to show that dy by dx equals a over x plus 1 to the power of n, where a and n are both constants that we need to find. And this is a 4-mark question. So essentially what we need to do is differentiate this expression for y. Now there are several different rules for differentiation that we can use. However, in this case I think we're going to use the quotient rule. And there's a snippet of the formula booklet here, and the quotient rule is actually in the formula booklet. And I think the quotient rule will work here well because it's in fractional form. So we've got a numerator over denominator, which is the same form as the quotient rule. So we're now going to use the quotient rule to help us. So if we write f of x, and we're going to set this equal to the numerator, and then we're going to write out g of x and set this equal to the denominator of our expression of y. Now the reason I'm doing this is, as we can see in the snippet from the formula booklet, I'm sort of just matching up how they look in the formula booklet so I can use it to help me. So we see in the formula booklet as well, to work out the derivative of y, we're going to need to know the derivative of f of x and g of x. So if we work those out now, f dash of x, and all this notation means is sort of differentiating. So f dash of x is the derivative of f of x. So to differentiate this, okay, so we've got 5x squared. So we're going to bring down the power and times it by the 5, so we get 10. So we get 10x, and then we take 1 away from the power. So 2 take away 1 is 1. So it's just x. And again, we're going to do the same for the next part. So we've got the power of 1, we're going to bring that down. So we get times it by 1, so you just get 10 again. And take down the power, so 1 to 0. Anything to the power of 0 is just 1. So this is our expression for f dash of x. We're going to do the same for g dash of x. And this time it's a little bit more complicated. We're going to have to use the chain rule. So using the chain rule in this, first thing we need to do is the same as normal. We're going to multiply down the power and bring it to the front. So we've got 2. And then we need to multiply this by the derivative of whatever's inside the bracket. Well, the derivative of this is just 1, because the derivative of x is just 1. And then a constant, when you differentiate something, the constants just go. So we've multiplied that by 1. Now the last thing we need to do, we need to multiply that by the whole expression, but take 1 away from the power. So this means you get x plus 1, and 2 take away 1, so you get 1. So that equals 2x plus 1. Now in this situation, this actually worked out quite simply, because the derivative of inside the bracket was just 1, so it didn't make a difference. However, often it does make a difference, so you've got to be really careful when using the chain rule. So writing this down over here, we've got 2 multiplied by x plus 1. Brilliant, so now we're actually going to use the quotient rule. So we can say that dy by dx. So we have f dash of x, so that's 10x plus 10. Multiplied by g of x, so x plus 1 squared. Take away f of x, that's 5x squared plus 10x, multiplied by g dash of x, so that's 2. So what I'm actually going to do to make it a bit easier, so I'm going to insert the 2 here, so it's multiplied by the 2, and then times the x plus 1 here. Fantastic, and that's all over g of x all squared. It's x plus 1 squared all squared. However, using our rules of indices, we know that this we can simplify down to just being to the power of 4. Also, notice the use of brackets here. Using brackets like this will make it much easier when we're expanding out. So we want to expand this out and simplify it. However, we don't really want to expand all this because it'd be a big mess. So we want to try and look to see if there are any things we can do. And there is actually. We can see that we've got a common factor of x plus 1. So we can take out a common factor there, there, and there. So I'm going to write that out below so it's just a bit simpler to see. So now what I'm going to do is expand out the brackets in the numerator and see if anything sort of cancels out with each other. So we have 10x times by x, we have 10x squared. Plus we got 10x times 1, so we have 10x. Plus 10x again, because we got 10 multiplied by x. And plus 10, because 10 times 1 is 10. And then we're going to multiply this 2 with both parts of the bracket. So we're going to have minus 10x squared and minus 20x. And again, that's all over x plus 1 to the power of 3. And this is great because we've got lots of things which look like they might cancel. You see, if we combined both these 10x, we get 20x. And we've also got a minus 20x over here. So this minus 20x cancels with both these 10x's. We can also see here we've got a minus 10x squared, which cancels with the 10x squared here. So it's really simplified it down. And in the exam, make sure you're clearly showing what cancels out with a simple line like this, but make sure you can still see what's behind the thing you're crossing out, because you can get some marks for it. So if I write this out one last time, we're left with 10 all over x plus 1 to the power of 3, which is the answer. Now looking back up in the question, we see that it says show that dy by dx equals a over x plus 1 to the power of n. Well, this is great because we've got this in the correct form, and we've got a value of a being the constant is 10, and the value of n being 3. And that's great because they're both constants, and it says in the question that a and n are constants to be found. If we got a or n not to be constants, or we got dy by dx in a different form, we know we've likely made a mistake, so we can go back and find our mistake. But we got it in the correct form, so that's great, so we know we're on the right tracks. And it's been great because we've shown all our workings to show that question. So looking through to where we'll get the marks, you get 1 mark for using a correct method of differentiating, so in this case we use the quotient rule, and attempting to do that on the expression for y. So we've got 1 mark here. We got a second mark for this step here. So where we wrote out an expression for dy by dx using the quotient rule. However, it didn't need to be simplified, so before we cancelled the x plus 1. We then get a third mark for this step here where we do simplify it down and factorise or cancel out the x plus 1, attempting to simplify. Then we get the final and fourth mark right here where we get the correct simplified expression for dy by dx. Right, so we worked through part A and we found out what dy by dx is. Now we're going to work through part B. And part B says, hence, introduce the range of values for x for which dy by dx is less than 0. And this is just a 1 mark question. We can see in the question use the word hence. So it means that we need to use what's in part A. So our answer from part A when trying to answer part B. So it says dy by dx is less than 0. Well, we know what dy by dx is from part A. So now what I'm going to do here, part B, is I'm just going to replace dy by dx with what we worked it out to be. So that's 10 over x plus 1 to the power of 3 is less than 0. Brilliant. Now this is what we're going to try and solve and find the range of values for x for which this is true. Now we need to sort of think about this quite logically. If we think about this, less than 0 essentially means negative. So we need to work out when, for what values of x, this expression is negative. Now we see it's in fractional form, so we're just going to try a few things. In fractional form, if you've got a positive over a positive, well that equals a positive. So that is greater than 0. If you've got a positive and it's over a negative, that equals a negative. And that's less than 0. So we can see up here that this number is positive in the numerator. Therefore, the denominator needs to be negative for this condition to ever be true. So we're going to break this down even more. So essentially, what we're now saying is that x plus 1 to the power of 3 needs to be negative. So it needs to be less than 0. So now we've got a new inequality. Right, so now we're going to think about this in a similar way again. So we have something to the power of 3. If we have a positive number to the power of 3 equals a positive. If we have a negative number to the power of 3 equals a negative. So we need, breaking this down even further, x plus 1 should be negative in order for x plus 1 to the power of 3 to be negative, in order for 10 over x plus 1 to the power of 3 to be negative, or as it's saying here, less than 0. So writing this out in a clearer way, we've got x plus 1 needs to be less than 0. So if we take away 1 both sides, we get x is less than minus 1. And that is the answer. Also, just a quick check, if we look back up in the question, we can see that we've got a condition that x can't equal minus 1. Well, fortunately, it's good because in our final inequality here, x doesn't equal minus 1. It can't equal minus 1. However, in other questions, you might get an answer where it did equal minus 1. So you might need to adjust your range in the final answer, looking back up at the question to see if there are any extra conditions you need to be aware of. So this question was quite a lot of work. However, it's only 1 mark question. So looking at where we'll get the marks, you just get the 1 single mark for getting x is less than minus 1.